Hey guys, and welcome to the channel. Walter here, and in this video we are going to be diving into the topic binomial expansions for A-level maths. Now I have left a link for you to download the cheat sheet I'll be using in this video in the description. So without wasting any time, let's get into the video. Now before we get into how we perform binomial expansions, there are some operations that you need to know, operations that you will come across in this topic, which might be new to you. The first one is factorial notation. Now, in general, if you have n factorial, this is the same as n times n minus 1 times n minus 2 times n minus 3 and so on, all the way down to 1. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, and this equals 120. Another example is, say you want to find 5 factorial over 3 factorial. You can do that manually. So 5 factorial is 5 times 4 times 3 times 2 times 1 divided by 3 factorial, which is 3 times 2 times 1. Now we know that these will cancel out to get 5 times 4 for our result. Or you can express 5 factorial as 5 times 4 times 3 factorial, because the 3 times 2 times 1 is essentially 3 factorial. And this is over 3 factorial. Then we can cancel out the 3 factorials and we get the answer as 5 times 4, which is 20. Now, it's important for you to know that you can use your calculator to find factorials. For example, if I type in, say, 6 factorial, I get my answer. Now, some things to note, okay, some important factorials which you just need to know even by head are, firstly, 1 factorial is equal to 1. So you just need to know this. And 0 factorial is also equal to 1. So this is very important. Let's go to the next operation which you need to know as we are getting ready to look at binomial expansions, and that's combinations. So we use combinations to find what we call the binomial coefficient. So the combination n choose r, which is also written NCR, is equal to n factorial over r factorial of n minus r factorial. And this is for values of r ranging between 0 and n. And just like with factorials, you need to know that we can use the calculator, the scientific calculator, to find combinations. So that's basically how we do it. Now, some important things to note. The first one is that n choose 0 is always equal to 1. And next, n choose 1 is always going to be equal to n. And lastly, n choose n is always equal to 1. So this is very important for you to know. Now let's look at binomial expansions. Now, binomial expansion is a method of expanding a two-term expression in a bracket raised to a power. So we use n choose r to work out the coefficients in the binomial expansion. And remember, we said n choose r gives us the binomial coefficients. So the binomial expansion formula goes a plus b to the power n is equal to a to the n plus n choose 1 of a to the n minus 1 of b plus n choose 2 of a to the n minus 2 of b squared plus n choose 3 of a to the n minus 3 of b cubed, and so on, all the way down to b to the power of n. And this is where n is a positive integer. Now, there are some things I want you to take note of. I want you to note that this binomial expansion starts with a, which is the first term, raised to the power of n. And it ends with b, which is the last term in the two-term expression, raised to the power of n. Also, I want you to notice that the power of a, which is n, decreases as we go. So I think you can see here that here we've got n, then the next term is n minus 1, so it is decreased by 1, then n minus 2, then n minus 3. So the power of A decreases by 1 as we go. And at the same time, the power of B increases by 1 each time as we go. So B has a power 0 here. That's why we don't have any term in B. Then B has a power of 1, then a power of 2, then a power of 3, and so on, all the way till it attains the highest power possible, which is n. So this is very important. So how do we use this formula? Well, you're going to start by choosing the most appropriate parts of the expression to assign A and B. And then you simply substitute into the binomial formula and simplify. Let's have an example. This question says, find the first 3 terms in the binomial expansion of 2 plus 3x to the power of 5. So we're saying, for 2 plus 3x raised to the power of 5, we start with 2 raised to the power of 5. Remember, we are making use of this binomial formula. So next, that's going to be 5 choose 1. That's the binomial coefficient of 2 to the 4 of 3x to the power of 1. So notice how the power of 2 is decreasing and the power of 3x is starting to increase. Here we have 3x to the power 1, which means the next term is going to be 5 choose 2 of 2 to the power of 3 and 3x squared. So we can see the powers of 2 going 5, 4, 3, and the powers of 3x going 0, 1, 2. But we're just going to end here because all they want are the first 3 terms. So when we simplify this, we will get 32 plus 240x plus 720x squared. So that's how we do it. So next, we want to look at the general term of a binomial expansion. So the general term of a binomial expansion, a plus b to the n, is given by u sub r plus 1 is equal to n choose r of a to the n minus r of b to the power of r. So we use this general term of the binomial expansion to find individual coefficients or terms in a binomial expansion. An example that we can have is this one, which says, find the coefficient of x cubed in the binomial expansion of 2 minus a half of x raised to the power of 7. Right, so if we take this binomial that we have as being in the form a plus b to the power of n, that will mean that a in this particular case is represented by 2 and b by negative a half of x. N is 7, and here we are looking for the coefficient of x cubed, which means in this particular case r is equal to 3. So if we're going to substitute this into the general term of a binomial expansion, we will be having n choose r, which in this case is 7 choose 3 times 2 to the power of 4 times negative a half to the power of 3. So we just substituted into this general term formula. And if we simplify this using our calculator, we will get negative 70 x cubed. So the coefficient of x cubed in this expansion is negative 70. So that's how we do it. I hope you're enjoying the class. Now, I just popped by to invite you to my free live Zoom classes held every weekend at 1400 to 1600 hours GMT plus 2. So with these live classes, I intend to go in depth with all the concepts that you find difficult in A-level maths. And remember, these classes are free to join. So you can check the link, which is in the pinned comments, and enroll for these classes and let me help you succeed in school. So at this point, we want to look at some questions and I'll be demonstrating to you how to solve them. And the first set of questions we are going to be looking at are questions which are like find the coefficient of. All right. Like here on example 3, it says find the coefficient of x in the binomial expansion 2 over x of minus 3x raised to the power of 5. All right. So I'm going to give you a mechanical and effective way of solving these problems. So what you're going to do is you're going to make a little table like this one here, just a small one. And you're going to have your values of r. Remember the values of r in the binomial expansion always increase from 0, then 1, then 2, then 3, and so on, all the way down. Okay, let's just say 4 and going down. And we have the first term here as being 2 over x, so we have 2 over x, and the other term being minus 3x. All right, now the powers of the first term will start from 5 and they will decrease by 1 each time. So 5, 4, 3, 2, 1, and going down. The powers of negative 3 start from 0, then they increase 1, 2, 3, 4 as we go. So all the way down. All right. So we want to look for a combination of powers, okay, mainly focusing here, which will give us a term in x. So you can try them out one by one. But in this particular case, I want you to consider this here, all right, where we have, in this particular case, n is 5. 5 choose r, which is 3, of 2 over x to the power 2, because this represents the power, and of negative 3x raised to the power of what? To the power of 3. All right, so the power of 3. And the reason why I selected this particular set of powers is because that's the one which will give us x when we simplify it. I want you to watch this. 5 choose 3, choose 3, we get 10, right? So we have 10, and that's times, here we've got 2 squared, so that's 4. Let me just do brackets. So that's 4 over x squared. And here we got negative 3 cubed, which is negative 27 x cubed. And 10 times 4 times negative 27 gives us negative 1080. And here I want you to notice how when we divide x squared into x cubed, what we will get is x, right? So this is 1080 of x. So that's why this particular set of powers was the best, because that's the one that will give us a term in x, as that's what we're looking for. So for our answer, we are saying that the coefficient of x is negative 1080. So that's the answer here. So that's what you do. You select the correct pair of powers, which will give you the term that they are talking about. So let's see if we can answer the next example. And it says, find the coefficient of x in the expansion of 1 over x plus 3x squared raised to the power of 5. All right, so I'll have that small little table, and we will have it like this. And we have here r, then r starts from 0, then 1, then 2, then 3, then 4, and so on. Then the first term here is 1 over x, so we have 1 over x, and the other one is 3x squared. All right. Now the powers of 1 over x start from 5 and they decrease. So 5, 4, 3, 2, 1 going down. And the powers of 3x squared start from 0. So 0, 1, 2, 3, 4, and going down. Right, so we need to find the correct set of powers, which will result in us getting a term in x. All right, so the correct set of powers, we can consider this pair here, which will give us the highest power is 5. So 5 choose 2 of 1 over x to the power of 3. And that's of 3x squared to the power of 2. So power of 2 here. And we simplify it. Okay, 5 choose 2. So 5 choose 2 is 10. All right. So we have 10. And that's of 1 over x cubed. And that's of 9x to the 4. And I think you can see here that when we divide x power 3 into x power 4, we get x to the power of 1. And that will actually give us a term in x. Alright, so 10 times 9 is 90. So we have 90x coming out of this. So therefore the coefficient they're looking for is 90. And that's how we do it. Let's have another example. Here it says we should find the coefficient of 1 over x squared in the expansion of 3x plus 2 over 3x squared all raised to the power 7. So again, we will have this. And we have r. Then the first term is a 3x and the other term is 2 over 3x squared. R starts from 0, then 1, 2, 3, 4 going down. And 3x starts with the power of 7 because the highest power is 7 in this case. So 7, 6, 5, 4, 3. 2 over x squared starts with the power 0, 1, 2, 3, 4 going down. All right. So we're going to look for the correct set of powers, which will give us 1 over x squared. All right. So you're going to do trial and error. You try for when r is equal to 0, that's the power, 7 and 0. You try for 6 and 1. You try for 5 and 2. You try for 4 and 3 and so on. And you're going to find that this particular set of powers should do the magic for us, because that's going to lead us to having 7 choose 3, and that's of 3x 2 over 3x squared. All right, and that's to the power of 3. So we have a power of 3 here. So I'm going to do the calculation. All right, I'll use my calculator here. So we have 7 choose 3. So 7 choose 3, and that's times 3 to the power of 4, and that's times, and we have 2 over 3, and that's raised to the power of 3, and we get here 840. So 840, and for the x terms we have x to the power of 4 divided by x squared to the power of 3, which is x power 6. So x to the power 4 over x power 6 gives us 1 over x squared. So basically we have here 840 over x squared. So that's how we get the term in 1 over x squared. So we're going to say, therefore, the coefficient which the question requires us to find is 840. So 840 is the answer, and that's how we do it. Let's move on to another set of questions in which you're asked to find the term independent of x. So we have here on example 6, the question saying, find the term independent of x in the expansion of 2x plus 1 over x squared raised to the power of 6. Now, a term independent of x is a term that does not have x on it. All right, so we're going to make our little table here. And on this table, we have r, which is 0, 1, 2, 3, maybe 4 going down. Then we have 2x starting with the power 6. So 6, 5, 4, 3, 2 going down. Then we have 1 over x squared starting from 0, 1, 2, 3, 4 going down. All right. So to get a term independent of x, the powers should match so that they cancel out. Okay, the power of this term must be equal to the power of this term. Okay, so that the x's cancel out and we remain with a constant. All right. So in this particular case, if you do trial and error, okay, starting from the first one going down, you will discover that here is where we will have that happen, where we'll be having 6 choose 2, because this is r. So n choose r, which is 6 choose 2, of 2x to the power of 4, the power, and that's of 1 over x squared to the power of 2. All right. So let's do the calculation. All right. 6 choose 2. Okay, let me just bring my calculator up. All right. So we have 6 choose 2, and that's times 2 to the power of 4, and that's times basically 1, right? And this gives us 240. So we're getting 240 here, and you can see the powers cancel out. Okay, x to the power 4, and that's over x squared, which is x to the power 4. So x to the power 4 divided by x to the power 4, we get 1. So this term is what we'll now be having as a term independent of x. So 240 is the answer in this particular situation. Let's move on. And now we want to look at questions which involve the product of two brackets. And we're starting with example 7, which says we should find the coefficient of x squared and x cubed in the expansion of 2 minus x to the power of 6. Alright, so that's part 1. Alright, so when we consider the expansion of 2 minus x to the power 6, and here we want specific terms in the sequence, we can consider the general term of the binomial expansion, which is n choose r, a to the n minus r, b to the r. So we know that for the term in x squared, r is basically equal to 2 in this particular case. Alright, so we are saying here this is going to be 6 choose 2 of a. A is the first number in the pair, so that's 2 to the power 6 minus 2, which is 4, and that's of negative x to the power of 2. Alright, so this is going to give us, okay, if we do the calculation, alright, let me just do the calculation real quick. So that's 6 choose 2, that's times 2 to the power of 4, and that's times negative 1 squared. So this gives us 240 here. So we get 240 x squared. So therefore the coefficient as required is 240. Then for the term in x cubed, r will be equal to 3. Alright, so in our case we're saying that 6 choose 3 of 2 to the power of 6 minus 3, which is 3, of minus x raised to the power of 3. And this is going to give us, if we bring up our calculator, that's going to be 6 choose 3, and that's times 2 to the power of 3, so 2 cubed, and times negative 1 cubed, which is a negative. So we get, we're going to get negative 160 then. So that's negative 160 x cubed. So therefore the coefficient is equal to negative 160. So that's what we'll be having there. Let's go to part 2. On part 2, they say we should find the coefficient of x cubed in the expansion of 3x plus 1 of 2 minus x to the power 6. Alright, so we're looking for the coefficient of x cubed. Alright, now you need to understand that when these two brackets are expanded, the 3x plus 1 times the second bracket, for us to get a term in x cubed, 3x has to multiply a term in x squared for us to get a term in x cubed. And 1, okay, has to multiply inside the second bracket a term in x cubed. So that's what has to happen in order for us to get the coefficient of a term in x cubed. So basically, we'll be having 3x multiply a term in x squared. All right, a term in x squared. Remember, we got something here. We got that the term in x squared, the coefficient is 240. So it has to be times 240 x squared That's going to be plus 1. We'll multiply a term in the second bracket to give us a term in x cubed. So that's a term in x cubed. And the term in x cubed, we've already determined that to have a coefficient of negative 160. So it's times negative 160 x cubed. All right. So we essentially have 720 x cubed minus 160 x cubed, which will give us, well, 560 x cubed. All right. So therefore, since they want the coefficient, we'll say that the coefficient of that term will be equal to 560. So that's the answer we get in this particular situation. Let's have another example. We're looking now at example 8, and it says, we should find the coefficient of x squared in the expansion of, on part 1, 2x minus 1 over 2x raised to the power of 6. All right, so we do the table again. All right, so we do the table. This is r, 2x, negative 1 over 2x, 0, 1, 2, 3, 4, going down. 2x starts with the power 6, so 6, 5, 4, 3, 2, then 0, 1, 2, 3, 4, and so on. So, to get a coefficient of a term in x squared, to get a term in x squared, well, the difference in the powers has to be 2, all right? And this is where that's possible, all right? When r is equal to 2. If we do 6 choose 2 of 2x raised to the power of 4 and minus 1 over 2x raised to the power of 2. Remember, these are the powers, right? So we're going to do the calculation here. So we're saying 6 choose 2, and that's times 2 to the power of 4, and that's times negative a half. Okay, so 0.5 squared. All right, this gives us 60. All right, so 60 x squared is the term. Okay, that's the term in x squared. So the coefficient of that term is 60. All right, let's go to part 2. Part 2 says we should also find the coefficient of the term in x squared in the expansion of this. All right, so we will get a term in x squared when the bracket 1 plus x squared, which is multiplying the second bracket, okay, and inside the second bracket we should be having a term in x squared, because 1 has to multiply that term to give us a term in x squared. And we should have also a term, okay, let me write that properly, a term in, actually a term independent of x. So I'll just say here, a term independent of x. All right, so that's what we need. All right, so 1 has to multiply a term in x squared so that we get a term in x squared in the product. All right, so the term in x squared, we already know that it's 60x squared. So 1 multiplies 60x squared, and that's going to be plus x squared. X squared has to multiply a term independent of x in the binomial expansion for us to get a term in x squared. So the term independent of x, this should happen when r is equal to 3, because that's when the x's will cancel and we get a term independent of x. So that's when r is equal to 3, right? So that's basically 6 choose 3, all right? And that's of 2x to the power of 3 and negative 1 over 2x raised to the power of 3. All right, so that's going to be 60x squared plus, and simplifying this thing we got, let me use my calculator. real quick. So we have 6, choose 3, and that's times 2 cubed. And we have negative a half, so times negative 0.5, and that's to the power of 3. And we get negative 20. So this whole thing gives us negative 20x squared, which gives us 40x squared. So that's the term. So the coefficient, which is the one they want, is actually equal to 40. And that's how we do it for this particular question here.